So welcome back to ENS161, Statics of Rigid Bodies. We are now on module 5.2. So this is part 2 of our module 5, which is Centroids by integration. So for this lesson, we will be discussing centroids by integration and the theorems of Pappus-Guldinus. So by the end of this module, you should be able to determine the centroid of a body of various shapes, so it could be lines or areas, by integration, and solve surface area and volumes using the theorems of Pappus-Guldinus. So the centroid of an area bounded by analytical curves that is defined by algebraic equations is usually determined by evaluating the integrals. So we need to integrate yung curve kasi wala siyang definite na shape. Hindi siya sphere, hindi siya rectangle, triangle. Yung boundaries niya is hindi siya parang mga curve lang siya, which is mayroon siyang given na equation. So for that types of shapes or areas is solve natin yung centroid niya using integration, of course. So yung previous natin na formulas, which is x bar, the first moment with respect to y is equals to x bar times area is equals to integral of the x bar of the element dA. So this integral part here, ito yung i-evaluate natin to determine yung first moment or yung centroid ng areas natin, which is bounded by analytical curves or algebraic equations. So take for example here more like a quarter sphere na a quarter circle na area, but it is not a quarter circle. So this line here, ito, so this is say this is equation y equals to fx, no? Okay, so in determining the centroid of this area given bounded by a algebraic function, so this is achieved by choosing dA or a small area, very small area, elemental area, to be a thin rectangular or strip. So say for example, kukuha tayo ng strip lang siya, like manipis lang na part. So this itong part na to, no? Okay, so this part. So say this is a rectangular strip with length y and with dx. So very minute din na x. So our x bar here, so yung center ng rectangular strip na to is of course dito sa center. So our xel is yung distance x natin, and the y bar of this centroid of the elemental strip is y over 2. So hindi natin i-consider na dx over 2, no? Kasi maliit na siya na value eh. So if for example yung thickness is 0.000001, so kung divide mo pa ng 2, so parang negligible na siya. So that's why kukunin mo na yung distance niya is yung x na. So yung area niya is dx multiplied by y. So yan yung area natin. So ito yung isa-substitute natin na values x, y, and y dx dito sa formulas natin to determine yung x bar and yung y bar natin. That is the coordinates of the centroid. So pag na-substitute na natin yung values, which is yung appropriate na values ng xel and dA, yel, and s in terms of x and y, so that's in that way ma-perform na natin yung integration. So this is a single integration. So meron ding double integration, no? But sa topic na to is we will only be using single integration. So pag na substitute mo na yung appropriate na values, so mapo-perform mo na yung integration and makukuha mo na yung values given yung mga values natin. Now, in doing integration, centroid by integration, meron tayong three common types of elements. So that is um, the vertical na strip. So this is the vertical strip. Ito. So kukuha tayo ng vertical strip, and then determine natin yung area niya, yung y bar, yung area, then yung mga coordinates. And then, depending on the shape or structure ng area natin, we can also use horizontal strip. So, horizontal strip, so we will also get the x bar EL, y bar EL, and the area. So, meron tayong itinatawag din na pie shape. So, ito yung pie shape. So, para siyang somewhat like triangular na ano. So, etong pie shape na to is used when the equation of the curve bounding the area is given in a polar coordinates. Meron radian siya. So, meron tayong angles na involved. So siguro sa mga arcs, mga ganun. So, may mga given na theta at saka radius. So, yun yung polar coordinate. So, the centroid of the triangle is 1/3 from the itong malaking side. But from the tip, it is 2/3. So, 2/3, 2/3. So, yung 2/3 is ito siya. But to get the vertical and horizontal component is, of course, gagamitin natin yung theta. So, for x bar EL, that is 2r over 3 cosine theta. And for y bar EL is 2r over 3 sine theta. And so, the area is 1/2 r squared d theta. Okay, so ito yung tatlong elements in determining centroids by integration. So vertical strip, horizontal strip, and pie shape na strip. So when a line is defined by an algebraic equation, so for a line naman, so meron tayong line lang. So its centroid can be determined by evaluating the integrals also. So same process, but dl na lang siya. So x bar L is equal to integral of x dl. So we will express the values into its appropriate differentials para ma-perform mo yung integral mo. So you have the equation. So, meron tayong algebraic equation, then substitute mo, makuha mo yung mga values niya. So, anyway, magbibigay din tayo ng example para mas maintindihan natin. So, theorems of Pappus-Guldinus. So, these theorems, which were first formulated by Greek geometer Pappus during the 3rd century Anno Domini, and later it is restated by a Swiss mathematician, Guldinus. So that's why it is called Pappus-Guldinus, which this theorem deals with the surface and bodies of revolution. So take for example here a semicircle line. So imagine niyo, no? So kailangan natin ng imagination dito. So this circle arc here, if you will to rotate that at this axis, itong axis na to, ipa-rotate mo siya, ano yung mapo-form na shape or mapo-form na body? So yung mapo-form niya is sphere, but hollow sphere. So since line lang siya, it is only a line, so magpo-form siya ng hollow sphere, say parang ball. So hollow siya sa loob. So this line naman, this diagonal line AB, so if we rotate it at this axis, magkakaroon tayo ng anong shape? So magkakaroon tayo ng cone shape. So parang yung cone ng ice cream cone. So yun yung magiging shape natin, yung cone. So may hollow siya sa gitna. And this circle naman, if you were to rotate it at this axis, so magkakaroon tayo ng torus or ring. So parang donut, parang donut, no? So this process is called the surface revolution, which is a surface which can be generated by rotating a plane curve about a fixed axis. So curve or a line, no? So if you rotate this line or curve, magkakaroon tayo ng surface, which is yung yung surface ng sphere natin. So kukuha natin yung surface area. So yun yung makukuha natin. So, likewise, meron din tayong tinatawag na body of revolution, which is a body which can be generated by rotating a plane area about a fixed axis. So, yung kanina, we have a semicircle arc, but ngayon is semicircle na area. So, if you were to rotate this semicircle na area, magiging sphere siya, but solid sphere na siya. So, solid sphere na siya, no? So, walang hollow na part sa loob. So, for this triangle naman, if you were to rotate this area, magkakaroon tayo ng cone, but solid din na cone. So, hindi na siya hollow. So, it has a body. So, solid na body. And same for this circle, it is also a ring or torus, but solid na siya. So, ito yung body of revolution. So, you will rotate a line or a curve, that is surface of revolution, and then rotating a plane area about a fixed axis, that is a body of revolution. So yan yung theorems of Pappus. Yun yung idea ng Pappus-Guldinus. Now, theorem 1 of Pappus-Guldinus is the area of a surface of revolution, so surface of revolution, is equal daw to the length of the generating curve times the distance traveled by the centroid of the curve while the surface is being generated. Okay, so para mas maintindihan natin, so say for example here a curve here. So this curve, no? So this curve. So kukuha tayo ng maliit na value ng L. So that is, so for example, this curve is length L. And then, ito pala. So length L. And then, kukuha tayo ng maliit lang na portion. So, that is DL. Okay, so, DL, so meaning, if you rotate this small portion DL here, magkikreate siya ng ganitong surface. So, that this is circular, no? So, naka-ano lang siya. Parang 3D view. So, naka-circle siya. So, this is circular. So, it will create a surface area dA. Now, the distance traveled here, so length, for example, is DL or L, and the distance traveled is, so pag mag-rotate ka ng full circle, the distance traveled is yung circumference. So, what is the circumference of a circle? That is 2 pi multiplied by the radius. So, in this case, for example, meron tayong y bar since the reference for the travel distance is by the centroid of the curve. So, since this is a curve, the centroid is located somewhere outside. But if straight line siya, yung centroid niya is of course nandito sa gitna. So, but sa curve, say this is the centroid and this is the y bar. That is with respect to the yung axis na i-rotate natin. So, that is 2 pi y bar. So, the theorem is the area daw of the surface revolution is equal to the length of the generating curve multiplied by the traveled distance by the centroid of the curve. So, meaning that is, kung dito na part, that is L multiplied by 2 pi y bar. So, ito yung magiging ano natin. So, yung area natin is equals to 2 pi y bar, 2 pi y dl. So, yan yung theorem niya. So, the area of the surface revolution is equals to the distance multiplied by the, the length multiplied by the traveled distance in reference sa centroid. Okay, so if you integrate this, so integral of dA is A, so magiging integral of 2 pi y dl. So, since 2 pi is constant, ipapalabas natin yung 2 pi, magiging integral of y dl. So if you remember the previous problems natin, the integral of y dl is equals to the y bar L. Okay? So, isa-substitute natin yung y bar L dun sa integral y dl. So, maging area na lang natin is 2 pi y bar L. So, yan yung ganun lang. So, meron tayong alam mo yung y bar, which is the centroid of the area or the line na i-rotate natin, multiplied by the length na or yung area, no? So, that is the theorem of Pappus, theorem 1 of Pappus-Guldinus. So, that is for the surface revolution. So, yung length multiplied by the distance traveled, which is the circumference of a circle, taking the radius, taking the y bar as the radius. Now, the theorem 2 is that the volume, so ito naman is volume kasi this is a body of revolution na. So meaning solid na siya, so meron siyang volume. So the volume of the body of revolution is equal to the generating area. So this time naman area, so pareha lang sila ng theorem 1 but this time area na lang siya, and then multiplied by the distance traveled by the centroid of the area while the body is being generated. So say this ano here, so this area, so area, so anong shape ba to? Parang shark fin. So for example, this area here, so kukuha ka ng very small area, ganyan. So i-rotate mo yung area na yan, mag-create siya ng body or volume. So, same pa din, the travel distance is 2 pi y bar, no? So, but y bar, take note that y bar is with reference to the center of the area. So, dv is equals to 2 pi y dA. So, this, so elemental area. So, and then, yung ano niya is y. So, that is the differential volume. So, you integrate. So, magiging integral of 2 pi y dA. So, constant yung 2 pi. So, papalabas natin sa integral. So, matitira na lang is integral of y dA. So, sa previous din natin na mga discussions, integral of y dA is equals to y bar A. So, we will substitute this value dito sa integral. So, yung volume natin is equals to 2 pi y bar A. So, that is the theorem 2. So, the volume, yung volume daw is equals to the body of the volume of body of revolution is equal to the generating area. So, yung area natin multiplied by the distance traveled by the centroid. So, distance traveled is 2 pi r. But the r here is yung y bar, which is yung location ng centroid natin. So, 2 pi y bar A. So, yung difference na sa 1 is L yung kanina length. So, this time naman is area na siya. So, that is the theorem of Pappus-Guldinus. Okay, so let's have a sample problem. Okay, so sample problem 5.4. So, determine by direct integration the location of the centroid of the parabolic spandrel. Okay, so this is a parabolic spandrel where yung this curve here, this curve is defined by equation y equals kx squared. Okay, so sa math natin, we'll be first determining yung k natin, yung constant. Okay, so y is equals to kx squared. So if we let x is equals to a, since the distance here is a and y is equals to b, and then isa-substitute natin siya doon sa equation, so magiging b is equals to ka squared. So yung k na lang natin is equals to b over a squared. Okay, so pag isa-substitute natin yung k doon sa equation, so magiging y is equals to b over a squared x squared. So yan yung equation natin. Okay, so meron na tayong value ng k and yung y natin is in terms of abx na. So we'll now determine the centroid by direct integration. So we'll first try to solve it via vertical differential element. So meaning vertical strip yung gagamitin natin. So this vertical rectangular strip here, yung area niya is y dx. So area, yung ganyan, no? So area is equals to the integral of dA. So which is, yung dA natin is y dx. So yan yung dA natin. Ito siya, ito. So y dx. So meron naman kayo mag-integral, no? So you'll substitute the value of y, which is ba squared over x. So that is ba squared x squared dx. Okay, so ano yung limit niya? So that is, so since vertical strip siya, so yung limit natin is from 0 to a. Kasi ito yung takbo ng vertical strip. So from 0 papuntang a. So, diba integral is the summations. So yung summation ng lahat ng mga vertical strip from 0 papuntang a. So that is 0 to a. Okay, so this equals to b over a squared. So integral of x squared is dx is x cubed. So x, so magiging 2 plus 1 over x 2 plus 1 over 2 plus 1. So that is x cubed over 3. So that is from 0 to a. So first, yung value natin is, okay, so substitute yung value from 0 to a. So since 0 siya, so dalawa, no? So b a squared. So 0 yung isa. So a na lang yung gagamit niya. Kasi pag substitute mo 0 sa equation, magiging 0 din. So x cubed, so that is a cubed over 3. So cancel yung a squared, a na lang yung matitira. So yung area natin is AB over 3. So yan yung area natin. Okay, so now that we have solved the area, so solve naman natin yung x bar and yung y bar. So the first moment of area with respect to y-axis, so that is qy is equals to the integral of x bar el dA. So x bar el is x and dA is y dx. X, y, dx. And then we form the limit from 0 to a. So yung y natin is b over a squared x squared dx. Okay, so x times x squared is x cubed. So by performing the integral, magiging x to the 4 over 4. So yan yung value niya. So evaluating from 0 to a. So the value will be equals to b a to the 4 over a 4a. A squared 4 a squared. So cancel out yung a squared, matitira lang is a squared. This is equals to a squared b over 4. So this is the x bar. So this is the x bar na. Hindi pa pala. Okay, so yung first moment with respect to y is a squared b over 4. So first moment with respect to y is x bar times a is equals to the integral of xcl dA. So magiging x bar is x bar times area, which is ab over 3, is equals to a squared b over 4. So ngayon, yung x bar natin is equals to, ilan na ba to? So cancel yung a, cancel yung b. So matitira lang is isang a, so that is 3/4 a. So yan yung x bar. So this is the x bar, yung centroid, and yung area is ab over 3. Naman, we'll try solving yung y bar natin. So y bar is determined using the first moment with respect to x, y bar L dA. Okay, so y bar is y over 2, dA is y dx. Okay, so substitute natin yung ano. So this is, so since the long y, magiging y squared. So 1/2 y squared, which is, yung y natin is b over a squared x. So b over a squared x, x squared, squared kasi magiging, ito is magiging 1/2 y squared. So 1/2 y is b over a squared x squared. So and squared na naman dx. So this is equals to, ilan na ba to? So we will integrate, we will evaluate this. So magiging, okay, konti-konti na natin, no? So squared of b over a squared x squared is b squared over a to the 4 times x to the 4 over x to the 4. Okay, dx. So yung integral niya is from 0 to a integral 1/2 b squared over 8 a to the 4. So integral of x to the 4th is x to the 5 over 5. So we'll evaluate this from 0 to a. So answer na natin is magiging b squared over 2a4 times a to the 5 over 5. So this is equals to a to the 5 b squared over, okay, simplify na lang natin. So a to the 4 to a to the 5 is a na lang. So magiging a b squared over 10. So ito yung first moment natin with respect to x. A b squared over 10. So since y bar is equals to a is equals to the integral of y bar L dA, so that is yung qx natin. Okay, so y bar is equals to, then yung area natin, area is AB over 3. So y bar AB over 3. Integral of y bar EL dA is AB squared over 10. Okay, so simplify the equation. This will give us y bar is equals to, so 3 over 10. Magka-cancel out yung A. Matitira lang is isang B. So 3 over 10 B. So this is for the y bar. Okay. So if we try to solve this via horizontal differential element, so naturally, makukuha natin yung same na value. So if you evaluate yung qy and yung qx, ito din yung makukuha natin. A squared b over 4 and ab over 10 for qy. So you will substitute this doon sa x bar a and y bar a. So makukuha nyo yung x bar and y bar, which is same lang din. So the area is equals to AB over 3. X bar is equals to 3/4 A, and Y bar is equals to 3 over 10 B. So yan yung mga sagot natin. Okay, so ganyan. Yan yung pag-perform ng integration, finding the centroid by integration. So meron siyang ganun yung process niya. So we'll find first the area, and then yung X bar and Y bar using the area by integration. Okay, so next problem. Sample problem 5.5. So determine the location of the center of the arc of a circle shown. So since the arc is symmetrical with respect to x-axis, so of course yung centered niya is along somewhere here na axis. So meaning yung y bar natin is equals to 0 na. So 0 na yung y bar natin. So obvious naman, no? Kasi somewhere here yung magiging centered natin. Say dito. So x bar na lang yung hahanapin natin. So by integration, so yung kanina, L is equals to the integral of dl is equals to, so that is, so dl natin is, so yung dl natin, so this arc, so kuha tayo ng maliit lang ng distance ng arc. So ano yung formula ng arc? So arc, S, yung sa math natin, arc S is equals to the radius multiplied by the angle bounded between the arc. The arc. So sa case natin, dl is equals to rd theta. So that is rd theta from, of course, from positive na alpha and negative na alpha. So this is a polar coordinates na. So polar coordinates na. So this is in terms of radius and angle na. So from negative a to a, from a to negative a. So since r here is constant, so pwede natin ipalabas yung r natin. R, integral of negative a, negative alpha to positive alpha d theta. So that is this is r theta from alpha to negative alpha. So if you evaluate this, r times alpha minus r times negative alpha. So magiging positive siya. So magiging 2r alpha. So yan yung length natin. So 2 times the radius multiplied by the angle. Okay. So the first moment of the arc with respect to y-axis is qy, which is equals to x dl. So x is equals to, x here is r cosine theta, and dl is rd theta. So r cosine theta multiplied by rd theta. So this is equals to magiging, so R is constant, so pwede din palabasin yung R. So this is R squared integral of cosine theta d theta from alpha to negative alpha. So what is the integral of cosine theta? So that is negative sine theta, no? So by identity, meron tayong identity na integral of cosine theta is negative sine theta. So ang sagot natin is magiging negative R squared sine theta from from alpha to negative alpha. So if you evaluate this, magiging 2 R squared sine alpha, no? So yan yung QY natin. So that is for the QY. Okay, so since QY is also equals to X bar L, so we can say that X bar multiplied by length 2R alpha is equals to 2R squared sine alpha. Therefore, ang X bar natin is R sine alpha over alpha. So, cancel yung 2, cancel yung isang R. Matitira lang is R sine alpha over alpha. So, this is for the X bar, and area is 2R alpha, and Y bar is, of course, 0. Okay, so that is how you solve naman pag line na yung problem. So, substitute mo lang yung value ng equation. So, same process. Okay. Next problem. So, determine the area of the surface of revolution shown, which is obtained by rotating the quarter circle arc about a vertical axis. So, meron daw tayong quarter circle. So, this one. So, this is a quarter circle na arc. So, this is under surface of area revolution. So, that is the theorem 1 of Pappus-Guldinus. So, according to theorem 1 of Pappus-Guldinus, the area generated is equal to the product of the length of the arc or the line and the distance traveled by its centroid. So, if we figure out yung revolution niya, so we have arc here, semicircular na arc, a quarter circle na arc, and it will rotate at the y-axis. So, yung centroid ng nakuha natin, no, yung centroid ng quarter circle is 2r over pi with respect dito sa axis na to. So, this is 2r, given siya 2r, and yung radius. So, this is the radius for the quarter circle. So, yung x bar natin is 2r minus 2r over pi. Ganon. So, x bar is equals to 2r minus 2r over pi. So, if we simplify this, magiging, so palabas natin yung 2r. Matitira lang is 1 minus 1 over pi. 1 minus 1 over pi. So, the area daw is 2 pi y bar times L. So, that is for the surface area of revolution. So, substituting values, 2 pi y bar or x bar. So, depende sa gagamitin natin. So, this time, meron tayong x bar. Since we will be rotating it at the y-axis. So, yung distance natin is x bar. So, 2 pi x bar, which is 2r times 1 minus 1 over pi times length natin, which is ano yung length ng quarter circle. So sa circle, yung circumference ng circle is 2 pi r. So i-divide natin ng 4, that is for quarter circle. So yung magiging distance natin is pi r over 2. So yan yung length ng quarter circle. Pi r over 2. Okay, so if we simplify this equation, we will get 2 pi r squared times pi minus 1. So ito yung area natin. Area ng surface of revolution. So ganun lang. So substitute mo lang. So you'll have to find for the x bar or y bar and then yung length. After that, simple algebra na lang yung gagawin niyo. Okay? Okay. So sample problem 5.7. So the outside diameter of a pulley is 0.8 meters and the cross section of its rim is as shown. So ito yung rim daw niya. So the diameter is 0.8 meter. So with respect to the sa gitna rotating axis, yung distance natin is 400 meter, which is the radius. So knowing that the pulley is made of steel and that the density of steel is 7.85 times 10 to the power of 3 kilogram per cubic meter, determine the mass and the weight of the rim. Okay. So first, so kagaya ng pagkuha ng centroid, itatabulate din natin yung areas. So merong positive areas, merong negative areas. So in this case, meron tayong dalawang area. So first is the 50 by 100 na rectangle, which is the positive area, and the 30 by 60 na rectangle, which is the negative area. So this one. So that is why ima-minus natin doon sa larger na rectangle, which is yung 100 by 50. Okay, so for area 1, we have area positive 5,000. So that is 50 times 100 is 5,000. Y bar natin is with respect dito, the y bar is dy is 25. So 25 minus 400 minus 25, so 374 na lang matitira. So with respect to the main rotating axis natin. So the distance traveled is 2 pi times r, which is 375. So that is 2356. So the volume is area times yung traveled distance natin. So that is 5,000 times 2356 is equals to 11.78 times 10 to the power of 6 cubic mm. So for area 2, which is negative yung area natin, 30 times 60 is 18. And then y bar is 365. So why? Kasi 400 minus 20 minus 15. So minus 35 na yun. So that is 365. So 2 pi times r, which is 365 for the negative area. So 2293. So the volume is negative. Of course, we will consider the negative. So negative 18 times 2293. So that is negative 4.13 times 10 to the power of 6 cubic mm. So the total volume of the rim. So total volume of this area, if you were to rotate it along this axis, is 7.65 times 10 to the power of 6. Okay, so we have volume na and we have density. So we can solve for the mass and the weight of the rim. Okay, so for the mass is equals to density times volume. Okay, so this is equals to this is in cubic meter, no? So density is 7.85 times 10 to the power of 3 cubic meters. So the volume natin is 7.65 times 10 to the power of 6 cubic mm. Cubic mm. So, we will convert yung mm into meters. No? So, multiply natin ng sa 1 meter, meron tayong 1,000 na mm. 1,000 mm. Then, cube natin para maging mm cube na lang, meter cube na lang siya. Okay, so evaluating this equation, so our mass is equals to, matitira na lang is, so cancel the cubic, so matitira na lang is, this is kilogram, this is kilogram per cubic meter pala. Per cubic meter. So matitira lang is yung kilogram. So that is yung unit ng mass natin. So that is 60.0 kilogram. So that is for the mass natin. Okay, so next is yung weight. So weight is equals to mass times gravitational acceleration. So that is 60 kilogram times 9.81 meter per second squared. So meter per second squared is Newton. So answer is 589 kilogram meter per second squared or Newton. So yung weight ng rib natin. Okay, so by applying the theorems, we can solve volumes and also yung weights. Since weight is using density, related siya sa weight. So that in short, so the theorems of Pappus-Guldinus offers a simple way to compute the areas of surface of revolution and yung volume ng bodies of revolution. So conversely, they can also be used to determine yung centroid of a plane curve when area of a surface is generated by the curve, and also to determine the centroid of the plane area generating a volume. Okay, so last problem. So using the theorems of Pappus-Guldinus, so the centroid of determine, so the centroid of area of a semicircular area, and B is the centroid of a semicircular arc. So we recall that the volume and the surface area of a sphere is 3/4 pi r cubed. So this is pi. And yung surface area ng sphere is 4 pi r squared. So this is a known values, no? So sa math natin, respectively. So for a semicircular area, we have area is equals to pi r squared over 2. So since semicircular siya, so divide natin ng 2 and reduce r, and yung center natin is somewhere in distance y bar from the x. So wala na tayong x bar kasi yung centered natin is sa gitna. So this is sa symmetry nila. Okay, so yung formula natin, so the volume is equals to 2 pi y bar times the area. So we have volume which is 4/3 pi r cube is equals to 2 pi times y bar times area is pi r squared over 2. So yung unknown na lang natin is yung y bar. So therefore, y bar is equals to 4r over 3 pi. So ito yung centroid ng so yung value ng y bar natin is 4r over 3 pi. So Pappus-Guldinus, you can determine the volume, but if the volume is known, you can also determine the centroid of the body. Okay, so next is the centroid of a semicircular arc. So meaning, line na siya, no line. So kanina is area, ngayon naman is line na siya or curve. So the length of the curve is pi r for a semicircle. Now, so ma-generate natin dito is yung, if you rotate this curve, ma-generate natin is yung area. So area is 2 pi y bar times the length of the curve. So yung area ng surface area ng sphere is 4 pi r squared. So yung surface area ng sphere. So yung length niya is pi r. So the only unknown is yung y bar natin. So yung y bar natin is magiging, yan na, that is 2r over pi. So yan yung y bar natin for a semicircular arc. So that is how you apply the Pappus-Guldinus na theorems. So related yung volume or yung area doon sa location ng centroid. So yun lang. Okay, so I think we've had enough examples. So these are the reference. So thank you. This ends our module 5. So part 1 yung nauna, then part 2 to. So ends our module 5. So thank you for listening and have a good day.